right, lesson 1.6, part 3 is going to start out with example 5. It says the function g is a continuous function that is defined on the closed interval from -3 to 3. Use a graph to complete the table of g. All right, so we're just going to pull these ordered pairs. So -3 has a y value of -3. When x is -2, it's got a y value of -2. When x is -1, it's got a y value of -1. When x is 0, it's got that y value of 1. When x is 1, it's got a y value of 1. When x is 2, it's got a y value of 3. And when x is 3, it's got a y value of 0. All right, so on the axis provided below, we're going to sketch the entire graph of each transformation of g of x. So we're going to do the same stuff we've been doing, except for a and b. They're a little new. But then we're just going to use the table they provided. They wrote their table going across. They wrote it horizontally instead of vertically. No big deal. We can switch it up if we need to. All right, so let's look at A. So on A, it says g of the absolute value of x. So what we're going to do is it actually doesn't change our x values. Our x values will stay the same. And we will use the y value of the absolute value of x from the original table. So this one's a little weird. So we're going to do this, and then we'll talk about a kind of a shortcut to help us graph this. All right. So our x's are going to stay the same. So -3 to +3. And for this one, let's start at the bottom there. Let's start when x is +3. The absolute value of +3 is 3. So go to your original table. When x is 3, what is the y value? 0. When x is 2, the absolute value of 2 is 2. So go to the original table at the top there, and when x was 2, what was its y value? It was a 3. When x is 1, now let's take the absolute value of 1, which is 1. Go to the original table. When x was 1, what was its y value? When x is 0, we're going to take the absolute value of 0, which is 0. Go to the original table, find where x is 0, and what was its y value? It was a 1. So notice, the positive side stayed the same. Where I had the positive x's, they did not change. It's the negative side that's going to change on us. All right, so when x is -1, the absolute value of -1 is +1. So look on your table for +1 and tell me what its y value is. It's a 1. When x is -2, the absolute value of -2 is 2. So go to your original table. When x is 2, what is the y value? It was 3. And then when x is -3, we're going to take the absolute value of -3, which is +3. So go to the original table, find where x is +3, and give me its y value, which is 0. And so let's graph this. Actually, no, I'm going to start from the bottom. So 3, 0, 2, 3, 1, 1, and 0, 1. So notice this side here. From the y-intercept and the positive side, our graph stayed the same if you look back at the original graph. So the positive side stays the same. Now let's go ahead and do the negatives. What happened? It reflected the positive side over to our negative x's. All right, so positive x's stay the same. And reflect across the y-axis. Now, on this one, you must include the y-intercept. If the y-intercept is not in your original table, you have to include it in it, okay? Otherwise, this won't work. You'll have a mistake in it. You have to include the y-intercept. All right, well, let's look at B. B says the absolute value of y, and we do exactly what it says. Okay, we're going to take the absolute value of y. So this is only going to change those negative y values, because the absolute value of a positive y value is a positive y. So everything that is above the x-axis is going to stay the same, only what's down below is going to change it. Now I'm going to do a quick little sketch right here. It's not going to be perfect, okay? So the other one, it looks something like this, right? So everything that we have right here is going to stay the same. It's this piece here that's going to reflect up because of the absolute value of y. But the reason I want you to look at that is because if everything's going to stay the same, we need that x-intercept, and that is not in our table, okay? So what is, look at your original one, don't look at my little sketch there. What is the x-intercept at that point? It looks like it's negative 0.50. So up there in our table, we need to add negative 0.50 between negative 1, when x is negative 1 and x is 0. So I'm going to show you that. Now, my table's not filled out anymore because I had to erase it to move down to these. So right up here we had negative 1, oops, and we had 0, 1, okay? So right in here we need to put negative 0.5 and we need to put a 0, okay? So make its own column or something there. You need to have that point. All right, so now let's go do the table here. So for B, our x's are going to stay the same. Include that x-intercept, okay? So x's are going to stay the same. So we have what? Negative 3, negative 2, negative 1, negative 0.5, 0, 1, 2, and 3. And then we're going to take the absolute value of our y values. So when I'm looking at my y's, the first one there's negative 3. The absolute value of that is positive 3. Next one was negative 2. The absolute value of that is positive 2. The next one was negative 1. The absolute value of negative 1 is 1. The next one was 0. The absolute value of 0 is 0. My next y value was 1. The absolute value of 1 is 1. The next y value was also a 1, so the absolute value of 1 is 1. The next one was a 3. The absolute value of 3 is 3. And the last y value there is a 0. The absolute value of 0 is 0. And so we're going to graph these, but I'm going to start at the bottom again. So I'm going to graph that 3, 0, 2, 3, 1, 1, 0, 1, and negative 0.50. And I'm going to go ahead and connect these. If you look at that, that is the top part of our original graph. It's everything that was above the y-axis. It stayed the same. Now, it's the negative y's that we're going to change. So now we have negative 1, 1, negative 2, 2, and negative 3, 3. And so there is our new function, or our new graph. All right, so for the rest of this, it's just review stuff. So now we got g of negative x. So that means that it's going to affect our x's because it's going to reflect across the y-axis. And so for our x's, we're going to divide by that negative 1. Now you can or you don't have to include that x-intercept. Okay, it's up to you. I'm not going to since it wasn't in the original table. We just needed it for that 1, but you can. It's not going to change it. So I'm going to divide all my x's by negative 1. And my y's are all going to stay the same. And I'm going to graph those points. Now, the negative in front of the x, remember, it's a reflection across the y-axis, so I expect it to have switched the positive and the negative x's. So flip to the left and right. And so when we graph that, we can see that that is what happens. Okay, for D, we have g of 1/2 x. Well, again, that's going to affect our x's. What is that 1/2 x going to do? It's going to be a horizontal stretch by 2. All right, so we're going to take our x's and we're going to divide by 1/2, which is the same as multiplying by 2. So take your original x's and multiply them by 2. And our y's are going to stay the same. Oops. So we had that horizontal stretch. So if we were to pull this graph, the original one, from the left and the right, we'd have stretched it out, and it would get wider like it did. All right, E says g of 2x. Well, the 2 is going to affect the horizontal. It's going to affect my x's, and it's being multiplied. So when it's going to be horizontal, since it's being multiplied, it's a stretch or shrink. 2 would multiply by 2 normally makes it bigger, but we know x is the opposite, so it's going to be a shrink by 1/2. So a horizontal shrink by 1/2, if I take it from the left and the right and I squeeze it back together, it's going to make it more narrow. So what are we going to do to our x's? Well, it says 2 times x, so we know we're going to divide our x's by 2. And nothing affected my y's, so they're going to stay the same. And then graph this. So it's a very squished in picture of our graph. And then F. F says g of x minus 1. So we know that that x minus 1, the minus 1 is with the x, so it's horizontal. It's being subtracted, so it's a shift. Minus 1 is going to go to the right one. So what are we going to do to our x's? Well, it says x minus 1, and we're going to do the opposite. So we're going to add 1 to our x's. So take your original x's and let's add 1 to all of them. So negative 3 plus 1, negative 2 plus 1, negative 1 plus 1, 0 plus 1, 1 plus 1, 2 plus 1, and 3 plus 1. And my y's are going to stay the same. And there is our graph. All right, so that wraps up lesson 1.6. And so we are done.